Welcome back to another exciting edition of Watching Me Do Some Math. Hold on to your seats, because here we go. In today's lesson, we are going to look at how to calculate the area of a triangle using trigonometry. So, we looked at a couple examples in class, and I'm just going to run two more examples of straight mechanics. And hopefully, you're following along and you're able to do the same on your own. So the first example is a triangle where I have two side measures and an angle. If I kind of want to relate that to something familiar, remember we had rules of congruence and similarity with SAS. When I have this side angle side relationship, I'm going to use my area trig formula. And the area trig formula is that the area of a triangle is equal to the product of two sides and the sine of the angle between those two sides. So I need to understand what these letters represent, not just using the letters as they are. So in this triangle, DEF, the convention we use is the side across from the angle gets the letter name. So 7.5 is across from angle D, so this would be side D. 9 is across from angle E, so this is side E. This would be side F. And Bob's your uncle, I'm ready to go here. So in my application, the area of the triangle is equal to side E times D times the sine of angle F. Two sides and the angle between them, divided by 2. If I plug in the values, and that's the beauty of this formula, is I just get to plug in the numbers. We looked at why it works in class. A little tight here. Voila! 32.44 millimeters squared. Okay, so this formula allows me, or lets me avoid the step of drawing my own altitude, working out a trig ratio, and then using that altitude in the base times height formula. One step, plug it in, and you're good to go. So hopefully you understand why, and if you definitely understand why, then you'll have some comfort using this formula. Side angle side lets me use the area trig formula. Our second example, if I'm kind of referring, I've got an angle and a side. Well, I can't use that trig formula again. I'm just going to have to decompose. And when I'm decomposing, I'm going to draw an altitude down the middle of the triangle. I don't want to break up. I don't want to draw an altitude through my 28 or through my 37, excuse me, because I want to save those two angle measures. But what that gives me is two triangles. Triangle 1 on the left and triangle 2 on the right. So I work with those triangles individually. So triangle 1, something like this, a 28-degree angle and a 14 decimeter hypotenuse. And the sides I'm interested in, I want both these sides. So I'm going to call them x and y. And now I just need to use an appropriate trig ratio to find the value of x and y. So if I start with x is adjacent to 28, 14 is the hypotenuse. Adjacent and hypotenuse is the cosine ratio. So cosine of 28 is equal to x adjacent over 14, my hypotenuse. Cosine equals adjacent over hypotenuse. I'm going to solve for x. So 14 gets multiplied by the cosine of 28. That's exactly x. And that's about 12.4 decimeters. I'm just going to go one decimal place on this. Okay. Likewise for y is opposite 28 degrees. And again, I'm going to use the hypotenuse. Opposite and hypotenuse, that is the sine ratio. So sine of 28 equals y over 14. Opposite over hypotenuse. 14 times the sine of 28 is equal to y. And y is about 6.6 decimeters. Okay, so going back to this picture, I just found x here, which is part of the base I'm going to use, and y, which is going to be the height of the triangle. So now I just need the base of triangle 2, and I'll have base times height divided by 2. So triangle 2, pardon me for the sniffles. I had a pretty good Barry White voice going the other day, but now it's just a cold voice. Kind of sucks. Moving on. The green triangle, just going this way, had a 37-degree angle and a right angle. And you look at that and you say, well, I got nothing, except that we found y already. So y was this side, and that's 6.6. And I should be able to find the hypotenuse and the adjacent side. In this case, I'm only interested in the adjacent side, which I've just labeled W. W is adjacent to 37. 6.6 is opposite 37. Opposite and adjacent is the tangent ratio. So tangent ratio equals opposite divided by adjacent, and I'm going to solve this for W. So W would equal, W times tan 37 would equal 6.6, and then W would equal 6.6 divided by tangent ratio of 37 degrees, and I would get that W is approximately 8.8. I'm hoping 8.8. That's a lot of rounding there. Oh well, I'm okay. So I just found W. And what I have now is the base of the triangle and the height of the triangle, and I will use good old base times height divided by 2. Good old faithful. Base times height divided by 2. My base in this case is x plus y. I had x as, forgot it for a second there, 12.4. And W, 8.8. And my height, I had a 6.6. All divided by 2, and I have an area of, drumroll please, nuts, lost it, I'm going to say about 70, give or take. 70 decimeters squared. Decimeters times decimeters, decimeters squared, and I found another area, and we are done. Hopefully, if you have any questions, hopefully you have no questions. Who am I kidding? You got questions, so come into class ready for some questions and some answers and some good times as always. See you then. Oh, I just hit a button. I don't know. Okay, bye now.